talking a bit today. A lot of kind of fun things with the team, and that, without people, none of this works. So thank you to everyone. Moving ahead. So for this morning session, I want to talk about roughly two things. One is pretty exciting. So actually I see Chris Jones in the back there. So about a decade ago, we were both at Berkeley working on something crazy called program synthesis. Be talking a bit about what that means today. And then for the second half, I'm going to switch over to a bit more on the core Graphistry side. And you'll see they're actually very tightly related, but thematically, this is also kind of our annual community event, especially for the folks online who are throughout the world. It's a good chance to see what's happening with the company and the technology. So kicking it off on the generative AI side, I think a lot of folks have heard the term vibe coding, so very popular in the software engineering community. I'm not sure as many people actually have seen the actual definition of it, so I think it's useful to pause a second and reflect on why people are so excited about this. And so Andrej Karpathy, so one of the OpenAI founders, he says it's not really coding. So we're not into syntax. I'm not worrying about errors. I'm not thinking about semicolons. I just see stuff, say stuff, run stuff, and copy paste stuff, and it mostly works. And if it doesn't work, that's fine, because I just do the same thing until it does work. And then if it, maybe I just throw away at the end, or I switch tabs, or I move on, like maybe I clean it up. But I could work at a much higher level and much more productively. And this is resonating. And whether on the Graphistry team we're writing CUDA code and highly parallel Python, we're going to do some of the hardest code out there. We're going to use it. And likewise, everyone else, they're going to go into their VS code and get Copilot or Cursor. And so I think it's very telling on the right that Cursor, basically an extension to VS Code, fastest run to $100 million annual revenue in history. So something's going on here. But our problem is, I do use VS Code, but I'll be just as often in a Jupyter notebook, or I'll just be using Splunk. And I don't, I do care about Git and stuff, but when I'm investigating and doing data analysis, I don't live in VS Code. That's not where I live. And so we've been talking for the last few months in the team about what we call vibes investigating, which is like similar but different. And so I want to do a little demo here. I'm going to be kind of super short, but just to give a bit of a feel. So this is Louie. We'll kind of talk about as we go, but let me just start it off here. So I just asked, hey, Louie, pull 500 events from Splunk where red team 50K is where red equals 1. So we're going to be looking at some pen test team hacking some government system. Behind the scenes, I could basically have written that same command to do a data pull, like whether it was Splunk, we're going to talk about BigQuery later, Amazon Neptune, doesn't really matter. Behind the scenes, what's going on is Louie figures out which database it is, which table, how to run the query. Not only did I want to generate the query, but I also wanted to actually execute it. So it's kind of like a multi-stage reasoning, a multi-stage program. I didn't just want to get like some text out. I wanted to actually look at the data. And from a vibes investigating perspective, yes, I do care about the software, but for me to know that I'm actually doing the right work, I actually do data work. That means I need to look at the table. I'm like, okay, yeah, so indeed, all these log events, when the pen testers are active, that data is flagged with red equals 1. And I get this nice little interactive table. I can turn to charts, things like that. So from a vibes side, like if something goes wrong, I can kind of interact at these levels. Like I'm not kind of just at that VS Code level. I'm much closer to my data. And so, and we've been teaching Louie a bunch of different tools. So think of this as like kind of like a cross between a Google document that you might file in your case manager and a Jupyter notebook where you might do Python. But importantly, it's not Python first. It's just like human first. So let's do one more example. And so like I want to just see now what are the pen testers doing. And I happen to know very intimately the Graphistry API for drawing graphs, but Louie does too, and I can speak more intuitively at the level of like the analysis or how I might to another analyst. And so I want to visualize this stuff, like, it's Graphistry, I want to have a graph. There's a bunch of columns. I don't want to be very exact on it, I just know conceptually which are the columns and the types. And then behind the scenes, okay, like Louie generated some Python. If it's not the Python I want, I can actually look at it and say, hey, this is the Python I want or it's not. And then I can, instead of me editing the Python, I could just tell Louie to change it. And so in this case, it's a little off. In the interest of time, I'm not going to do it here. But you can imagine now my debugging experience is just editing. But the result though is like now we get this like nice interactive graph. Like I'll have like timelines. I can kind of see what all the, in this case, because we checked the query before, we're actually seeing like the pen testers are, for example, mostly working on this computer, but they actually reached a bunch of other devices, and I can kind of drill in, play through the session, see all that kind of stuff. Okay, let's jump back here. So I've been talking about vibes investigating as somehow different from coding, and I think it's useful to think about some examples. So on the right, on the left, we've been working with some of the friends of the company to think about how vibes investigating is kind of same but different. So on the left, there's a bit about coding. On the middle, about investigating. On the right, there are commonalities. So just a few quick examples here. So when I'm in code land, for example, I might be dealing with hundreds or thousands of files. I have a large code base. But when I'm in data land and I'm investigating, I have the same thing, but just like gigabytes or terabytes of data, or like I'm dealing with lots of database indexes, probably a lot of logs. That might be a little uncommon and similar for like you're an SRE. When I'm trying to make code run, I'm just trying to get it to pass the unit test. So as long as I get one path that works and pass all my tests, I'm golden. But when I'm doing data analysis, especially let's say in something in cybersecurity, I have more of an investigator mindset. I want to make sure I have no stone left unturned. If there's a fork in a road, if I'm just trying to get code to run, I just need to find any path that works. But if I'm an analyst, I actually have to follow both forks because the bad guy could be on either end. I have to have full coverage. So that's a little different. Likewise, when I'm actually collaborating with folks in code land, I might think about something like Git. I'm like trying to generate stuff and then save it and share it. But when I'm in analyst land, I might be thinking about like a case manager. I need to save not the code, but my workflow. And then when I'm done, it needs to go into like some sort of like wiki or a ticketing system. And so there are similarities, but there's also important differences. Some of them are kind of like workflow in UX. And so you're kind of seeing a bit of what we were doing before. And so with the AI notebooks and some of our other work, we're having a chance to sort of revisit the last decade of trying to bring Python into all these investigation analyst teams and kind of right a lot of wrongs and try to just fit into more of the investigator workflow rather than the kind of code workflow. You can do this is sort of like how Figma kind of changed how people, designers work. We're trying to do the same thing with investigators. But it's also, it's not just at the UX level, it's pretty deep. Like how an AI needs to work for code is a little different than how an AI needs to work for investigation. And so if you, like there's similarities, but if you treat it as the same thing, it's going to go wrong. And so you can stay for Alex's talk later today, and he'll go a bit more into that. So like I said, as we're building out Louie, one way to think about it is, yes, we're building tools you could directly use. AI notebooks, you just saw a little bit about that. You can share those. But you can create dashboards. You can create tools. You can create workflows. We don't have time today, but we're actually creating auto wikis. Like as events happen, as tickets happen, you're monitoring social media. You can actually automatically, almost like have your own team of journalists just building things up for you. Underneath, we do have to do a lot of work. So we'll talk about the AI stuff. Reality, a lot of our work is actually mirroring your environment. A lot of our data-intensive scenarios, you have a lot of kind of data silos that we need to connect together. We have a lot of APIs. People are experimenting a lot. Maybe they're making their own LLMs. They're making their own agents. And so we actually have to support connecting into all that stuff. We don't have time to go into those today, but reach out to me after. But I guess like the kind of a key part here is, as we're building out that AI, it sort of glues together all of it. Whenever anybody runs any Python anywhere, you want that team knowledge, that tribal knowledge. If anybody sees like an IP address that's interesting, if anybody writes a bit of Python code or a bit of Splunk code, You want that to go into that communal brain. That goes into Louie's learning loop, and that lets us build everything else. This is kind of this almost like an investigation operating system. So with that, one of our kind of questions at the beginning of the year was, well, how far can the AI can go? Like, are we just doing these like small interactive things, or could we run a full investigation? There's been a lot of startups kind of doing some fun things here, but I feel like a lot of times people are, doing a task like, oh, does a AI model, label text with MITRE, classifications, which is important, but that's not actually where all my time in an investigation goes. Or people say that they're doing well in an investigation, but it finds out that, maybe an MIT startup spends 30 minutes on an AI to do one task, and then some like VC-funded company says they can do in 5 minutes, but nobody ever shares a benchmark that you can run. You have no idea what's actually going on. Like if any, like I trust that MIT startup can do it in 30 minutes, but I don't know if that's actually helpful. And so we decided to, we're more data-driven and technology-driven. We like to back up our claims. And so what we found was Splunk actually does a really great job every year of something called Boss of the SOC, where they have tons of questions that analysts will join. Some are harder than others. I'll talk about in a little second. But these are not just like a simple query like I showed you, but like analysts will spend for the two series about maybe anywhere from 5 to 15 minutes to answer one question. So it's a multi-step question. For the 300 level, it'll easily take 20 minutes to an hour for one question. And if you have like 50 to 100 of these, you're going to need a team. And so people spend like an entire afternoon, 4 or 5 people, and chances are they're not going to finish. So we're curious, like, hey, could we not only do this, but could we speed run it? Could we do all of it in 10 minutes? So I'm going to first little announcement here is kind of show you. Hopefully this works. So take a little pause. So we decided to pit our intern against our former kind of government analyst. So on the left, Sindra is doing the normal task, so easily, for 200 level, 5 to 15 minutes. But when Evelyn is doing on the right, she gets to launch all 58 questions in parallel. And as they run, it's doing everything. It's like doing Python, doing Splunk queries. When it gets results back, it reads them directly, or it runs it through our AI log analyzer. It's actually, we bake in the investigator mindset, so we're actually doing a lot of that reasoning. Talk about that during Alex's session. So as that goes through. And it's actually pretty stunning that like all of a sudden, not only do we got an answer, but we actually got the answers validated. And like, so we'll actually have cross-validation go through. And so we're kind of seeing those start to come in. So here, Sindra's starting to use ChatGPT for a little bit of help. So, let that go through here.
A few moments later.
Okay, all right, so let's step back a bit. And so, thank you. Yeah. So I'd like to kind of report that we're sort of the first team to actually show speed running, not just a benchmark on the cybersecurity stuff, but the first time that an AI in an open competition basically pretty soundly beat like the typical human analyst. So to me, this is sort of like when OpenAI announced that for the medical boards, the legal bar exam, we actually had head-to-head competition on a professional domain. This is the first time that most analyst teams cannot do what I just showed you, and especially in the time I showed you. We're not saying this replaces the analyst by any stretch of the imagination, so let's just like work through what you just saw. So we have an auto close rate of 73% of the entire boss of the SOC competition. So that, first of all, that's a big deal. I do really like their separation of like the 200 versus 300 series. We had a 100% close rate on the 200% series. So no magic. What's more, instead of 5 to 15 minutes for each one, our median was about 2.5 minutes. That's already, and this is the stuff that people hate, to be honest. And so being eliminated, like change that. The 300 series, we've clearly got work to go. So this is our first attempt. This is, I think this is a good starting point. I like that we have more to do. There's a lot more we want to do. So, but we're already doing half of it. And instead of that 25 to 45 minute plus for an entire team of 5 people, we're auto-closing those also in 2 minutes, median. So this is already pretty awesome. The ones that we didn't solve, we actually solved most of them. Like, for example, the last step might be, checking some CVE website. We didn't actually hook up the internet to it. Oh, like, totally could do that. And so it's actually, to me, it's that 50%. We don't even need to hit 100%. Co-solving to me for the interesting stuff, that's actually where a lot of the real work happens. And so showing that, for example, instead of having to manually do, 10 hours of solving, if we could already do, 73% or eventually 90% of the work, we switch 10 hours of working to 60 minutes of validating, and then I can actually spend an hour of actual analysis for what I actually want to analyze. So this kind of shift it's no longer theory, but this is real. So you just saw it in front of you. Reach out to Alex, and he can actually do it live with you. I showed it for Splunk. There's no fundamental reason we need to stick to Splunk. Louie already uses multiple databases and within the same investigation. That's true of most of our customers, that maybe the account system and fraud is, for example, in Elasticsearch or in BigQuery, while the security logs might be in Splunk. Totally normal, and you need to do both when you're doing a real investigation. So let's see if we have this video load here. We're going to actually have some folks from the Google team later today. And kind of a little preview of, also kind of happy to announce today is, before we announced that we had Graphistry Python integration, but now you can actually talk to your Google BigQuery graph and your Google Spanner graph. Same thing that I just showed you before, but you're actually now, again, just working with it conversationally in this sort of vibesy way, or if you want to turn out into actual flows. And it's generating these like GQL graph queries for you. Okay. Let's switch over here. And on that note, I did want to do one more note here. One of the reasons I'm kind of excited to work with partners is because in turn we get to do more very exciting projects. So we'll have another speaker today, Razor, as part of the CISO panel. He's doing a really fascinating project, for example, with combining LLMs and Google Spanner Graph over in the government. They have all sorts of identity providers, multiple clouds, on-prem. You have all sorts of login and, oops. So I don't know if I can, Don or somebody could help here while I, talk about what's going on. This one is not planned. Okay. But yeah, so with Razor, it's a cool project where, thank you. All these data sources come in. Identity is a very natural, not just like the physical people and like it's a static of like what your assets and things you're protecting, but actually all the activity. Like for example, today you logged in from one ISP and then you flew out here to another. You want to do zero trust checking of like, is this actually the right identity? Very natural graph. Now that we're getting that all into one managed layer, we can do all sorts of detection rules on it. Graphistry, you can actually see it. And so this is actually a big deal. Imagine you're in a live incident. You actually want to understand who's doing what where. And as you're seeing with all the LLM stuff we're talking about, we're actually building out this semantic layer, not like a 1990s, 2000 style, but more of an AI era that we can actually understand how all the tools work together, and you could talk to it as you were seeing before. So Razor will be talking a bit about on his panel. So if this kind of stuff is interesting to you, let's talk. We're finally raising our head above catch air now that things are starting to kind of smooth out. And so we're definitely looking for fun partners. I'm going to share one more demo here. So switching over a bit onto the Graphistry side, we're continuing to roll out features. Louie, in a sense, is just ways for us to make Graphistry more accessible. Here, we're looking at that same government red team data set, And kind of blue is, let me actually pause this really quick. So what we were kind of seeing here is, well, actually, yeah, let me play it out, is the same data set. I think in green are computers and in blue are people. And then what we're going to see is some of them are those kind of pen testers. And what we recently added is a little feature. It's very subtle, but it's, in practice it's powerful, where I want to just grab a chunk of the graph. For example, any event where it was labeled as a red teamer, I'm going to make them all red. I just want to kind of point and click. I don't want to write any code. And so we just made a collection of anybody with that attribute. It's the red equals 1 attribute. And then we're just going to color that. And so now that instead of just having this like uninterpretable graph, we have this kind of nice, let's pause that right there. You know, we now have like very clearly any of that red team activity. Clearly the red teamers are mostly working on this computer. They reach some others. We can look at which accounts are active. That was kind of like a very just like handy point and click thing. The reason I wanted to share this was actually the next slide. So let's say I wanted to do like a bit more of an interesting analysis. Cool, so I have red teamers having some login events to the computers that they either immediately went into or the ones that they reached. So those are kind of normal events, you know, an event linking some entities. But I want to understand blast radius, like who else was on those same computers that the red teamer logged into. I can't just look at all logins, like obviously that's a ton. So I really want to have this like path expression of like, okay, let me find all the computers where a red teamer logged in, but also somebody else logged in. I want these people. And maybe I want also what other computers they do ad nauseum, but I really want this like path expression, right? The Neo4j company innovated this graph, almost like regular expressions for graphs, where you can do this really easy pattern matching. So I have that kind of example up here, where you could basically left to right of the same exact statement. I could write it in SQL or in Python pandas with lots of nested joins and stuff, and like you could totally do it. It might be slow, but more importantly, I never want to read this code, you know? This I could actually read and write and use GenAI with, and it's interpretable. And so the cool, so a couple of points. One is we can now do the same thing, but if it's like a small data set like I was just showing you above, I don't have to run an entirely separate database for it. I could just pip install Graphistry, import Graphistry, and run these like whatever my data table. Let's say I did a data pull from BigQuery or something. I just want to run on that data frame and do this expression. I could basically write the same thing and kind of do that same work. The reason I want to share that was that in our in the video, actually in interest time I won't show it, but I could actually define a collection using that same GFQL. And so if I want not just red equals 1, but I actually want blast radius, I can actually write down exactly what I mean by the blast radius, and inside the tool, I can actually have very precisely, I can color parts of it that way. Again, so I'll have to share folks with that after. Okay. The joys of morning keynotes is this slide does not fully exist. So what I wanted to share here is a couple of things. That same path expression that we're basically able to do, you can actually, if you have a GPU, and so I think we have some folks from NVIDIA here, we'll actually detect you have a GPU, and we'll actually run that on a GPU. And so, you know, a lot of bit about Graphistry is that could we actually, you know, we're not going to do the petabyte stuff that our database friends are doing, but if you're within your own investigation when you do that data pull, that same kind of type of query will actually run on the GPU, and you can actually, you know, pick. So, you know, come talk to me after about kind of like CPU versus GPU. Like I think both have their space, and so we make it so you can just flip. And then one of the things we're seeing here is we also released a bit, maybe a month or two ago, is the remote mode, where we're seeing our users starting to do this in a few ways. So for example, whenever they do have the visualization, kind of like I was showing you with collections, they could talk to it in GFQL. Let's say they made something yesterday, and then later they want to kind of ask a question about it. A lot of teams we're seeing is actually as part of their ETL pipelines, where they have like a regular ETL pipeline with like Databricks or Splunk or something, but then they want to do a little bit of like graph enrichment because it's feeding into an ML pipeline. You know, if you have like a 100 million row graph, it's kind of annoying to have to spin up a GPU cluster just for that one step. And so because we now have the remote mode, if you have that, like let's say, oh, take my event table, run PageRank or something, you can actually use the GFQL remote mode to just for that one step, pop out of your ETL pipeline, benefit from the GPU acceleration for that, like, you know, 2 minutes or whatever, like the thing that would have crashed your Spark cluster, but now you can get it on your way. There are other versions of like this that we're doing as well. Like for example, you can save these as sort of like workflows that we're finding people are to be kind of useful, so you're not sending code all the time, you're actually saving ways to do these. But again, talk to me after. It's been interesting to see what different enterprise teams are doing. So with that, I'm going to say thank you, and then maybe, Indus, if you want to start setting up the next one. Happy to do questions for a few minutes, or if we have anything online as well. Thank you.
Where else can I get a GPU accelerated graph?
Where else can I? Well,
Nowhere.
nowhere. Well, I think our partners, I'm going to say our partners at NVIDIA, but we're the ones who kind of make it a little more accessible. If you ever tried using one of those. Well, anyway, I encourage folks to whether me or somebody else on the team throughout the day, if you want to see some of this stuff in action, if you want to try your own Splunk queries, your own visualizations. It's been interesting trying to actually speed run something like as significant as what I just showed you there. So happy to share questions on that.
Yeah, I just want to add that if you are not using Graphistry to do your investigations right now, you're really behind. We were doing these graph-based investigations back in 2019. And back then, there was the huge SSL VPN exploit that came out at Black Hat. So I was at Black Hat when DevCore presented that exploit. And then I had it loaded in Graphistry, and we caught it, their initial arbitrary file read, maybe 3 to 4 months ahead of when the notice went out to everybody else. So you can't do that kind of analysis by going through the logs. It's just not possible. So there's a huge advantage there. And then adding Louie to it is a big deal. It just simplifies a lot of it. Splunk, to me, I've been using Splunk for years, but honestly, I was leaving Splunk. And that's why Google Spanner is here.
Yeah, and it's actually for us, it's for me, like data is sort of a full team sport where we'll come in and there might be a couple people who are awesome at Splunk for some part of their Splunk deployment, some other people who are awesome at Python for parts of their Python stack. But if you have a team of like 5 analysts or 20 analysts or 200 analysts, it's so diverse, and so that to kind of let people work together more easily, it just makes it more of a team sport. Simon, can you help me with the